assembly language module, it's best to start with a skeleton so you won't forget anything. I've got a couple of them I want to show you. They do the same things, either one will work, so you can just pick the one you like. The first thing that you'll notice is that the layout divides the code into segments. Some object file formats don't use segments, so the assembler just throws it away for them. It works in either case. The first segment is the data segment. It's for initialized data. Any declarative that has an initial value goes in here. All of the initial values are constructed by the assembler and stored in the object file, so when the program is loaded into memory, all the initial values are loaded also. The other segment for data is called the BSS segment. BSS stands for block started by symbol. The only thing stored in the object file is the size of the segment. The loader that puts the program in memory creates a space in memory for it when it loads it. Any references to variable names that are in this segment are references to offsets within the segment that appears on loading. Next comes the text segment. This is the segment that holds the executable instructions. It starts with a global symbol. This is the name of the function to be called. If this were a C program, the name would be main. That's the name of the function called by the runtime system to start the program running. So this will need to be some name known to another module that is used to call it. The first instruction here is called enter. You use it to save the context and set up the stack. You replace the letter N with the number of bytes that you want to allocate on the stack for local variables. If you don't want to declare any temporary local workspace, just use 0. The second argument has to do with nesting functions inside functions, so you can just consider it to be always 0. Next comes one or more push instructions. This is to save the contents of any registers that you will be using in your function body. Then immediately comes the function body. Finally, to exit the function, you restore all the caller's registers. You put the return value in a location the caller expects it. EAX is usually used for this. Then comes the leave instruction. It does the inverse of the enter instruction by removing the local workspace from the stack and restoring the original context. Then the last thing to be done is to return to the caller. I said I had two skeleton layouts. The other one is almost the same. The only difference is how the enter and leave code is included. This time, discrete stack and copy instructions are used instead of enter and leave. They do exactly the same things. The only differences are the enter and leave instructions take a few more clock ticks, but they're also a bit smaller. Anyway, written this way, you can see what enter and leave do. First, the previous caller's value in the EPB register is saved on the stack. Then the ESP register is copied into the EPB register. The subtraction of N is the number of bytes you're going to be using for your local variables. I'll have more about this a little later. Then you include whatever push instructions you need to use to save whatever registers you're going to work with, and you're into your function. To end the function, you simply undo what you've done. The first job is to pop all the saved registers. Then you store the return value in the EAX register. In this skeleton, the return value is 0. Then it's a matter of restoring the ESP and EBP registers to their original values. The final thing you do is return to the caller.